Welcome to introductory video number 4 of the Multiphysics for IronCAD series, and this video is about results. We've just briefly looked at results in the other video. We're going to spend a little bit more time to look at the results. This is the results of the meshing video. I'm going to go ahead and delete this simulation because we don't need it. And we're going to let's solve this one so we have something to look at. I'm going to scroll this up so that I don't have to scroll bars here. I'd rather have the scroll bars up there because I'm going to stay on the result menu down here. Right there, there's a section where you can change the relative spacing used for either the dialog down here or the tree up there. So this is the model that we've made where we have a force of 100 pounds applied to an aluminum cylinder here connected to a steel cylinder with a hole in it, and this edge is fixed. The one result things that we've looked at so far are the contouring. We've looked at both displacement magnitude contouring, and we've looked at the equivalent stress contouring. We saw that during this section of the model, when we had the force applied here, this had an area of 3 inches. We applied 3 square inches. We applied a force of 100 pounds and obtained a stress through most of the model without the hole of about 33 pounds per square inch. When we added the hole, we had more stress around where the hole is. When we added the aluminum, we got even more stress with the aluminum because it was a smaller surface. So the force was not applied to an area of 3, but something with a much smaller area, which gave us a lot larger pressure. So some of the things that we can do in looking at the results, we can click on the Inquire button to inquire by node. This allows us to move our cursor around and to look at the stresses or whatever we want to look at. There's our options of the processor output. We can look at these at individual nodes. For example, right now we're looking at node number 155. Up near the top it says the value of the stress is 138.274. The units for the stress are PSI. We can change the units if we're not happy with the units. Pounds per square inch, we can go to newtons per meter squared. Okay, and then as we activate this, as we move this around, this gives us the stress in newtons per meter squared. Result units are actually remembered. So if we go to the contouring, it now has units per meter squared. If we redo it, then our display is in units of newtons per meter squared. So this shows us how we can change the units used for our results. Let's go back here to contour display. Let me turn this off. One other thing is advanced results defaults to being on, and this shows you all of the FEA results that are available. This is what you want to use if you're an FEA expert, or if you're using if you want to see just what is available for the FEA results. If you're primarily interested in stress, strain, and deflection of the model, we can turn off advanced results. Then we see here that we have a much more limited choice, but they're easier to select. This includes the stress, the displacement magnitude, the displacement in the 3 different directions, and the equivalent strain. So we'll go back to let's go back to stress. We'll go up here to units. We'll tell it to use the default units for whatever coordinate system we're in. We are in, let's do OK. Our model shows that our default unit system is USA. We can actually change the unit system anytime we want. The length is fixed because a lot of the boundary condition parameters assume that they were entered with this length, and we don't want our results to change if we change our units. But We can change the unit system and it still leaves the length in inches regardless of what unit system we do, which still leaves our boundary conditions as they were before with the same values. And then we can look at results in different units if we're more familiar with that. Most people are just going to always leave the units the same, and the length units are going to match these units. Everything's going to match, and they're going to be happy with it. So we've discussed units for results. We go back here on results. We have the animation. We can pause the animation and go a step, go a little bit further or back in the animation. We can see the scale that's used for each particular slide of the animation. There's a save AVI command that lets us save this as an animation. We click on save AVI and it picks the default file name, which is the name of our sim with the .avi extension. Click OK, and we can select compression. Microsoft Video 1 usually works well. Click OK, and it's created a simulation. Let me pause this so I can find it on my computer. It's in the same directory as our model is. Okay, here's the folder it's in, the tutorial folder, and this is the block hole. 3 is the number of the simulation, and this is the AVI associated with it. I can double click on it. This brings up the standard Microsoft AVI viewer, and it's just essentially repeating the simulation. So this is a good way to show your FEA results to other people. This tells us the contour is a stress contour. So let me close this directory. Let's see. The next thing we can do is go over here to these buttons and put on a cutting plane. We can use the default cutting plane and move it through the model. If we wanted to use a cutting plane in a different direction, if I hold down, okay, there's cutting plane, and the text says toggle cutting plane shift to edit. So if I hold down the shift key and click on cutting plane, it gives me a lot more information. I can specifically give the direction, I can give a location on the cutting plane, or these are some quick things. I can say I want a cutting plane in the, let's say I want to do XY direction, so I go over here to XY. This gives me a cutting plane in the XY direction. If I want to look at the other side, I can reverse it. Don't want to do that now. And I can just click OK if I want to keep this as the cutting plane view. And within the cutting plane, I can see the contours within my model. I can also do an inquiry command where I go and inquire on nodes. Now most of the nodes in the cutting plane are artificial nodes, and so they'll have a negative node number. If you look over here for a negative node number, that means these are artificial cutting plane nodes. The negative node number means this is interpolated from the model. But we can do inquiries using the node inquire to inquire on nodes even within the cutting plane. Let me turn that off and turn off the cutting plane. We'll use it later. Other examples we have are doing plots. Plots are, you have more options with plots when you have a multi-step simulation because you can plot things as a function of the time step. If you just have a static simulation where there's only one time step, one of the more interesting plots is to select an edge. Let me go back to turn off the contouring so that we can see the edge I've selected. Come over here to plot again and select plot along direction using the current step. So the direction I have specified, the default direction is X, and I've specified a line that's pretty much in the direct X direction. So this essentially looks at the value of each one of the points on the line, and it plots it as a function of distance along the line. So if I look at the plot, here is my plot. I can turn this off, turn back on the contouring, and I can see that it starts at a medium range, and then it goes up to a blue range, which is fairly low. It goes up to a higher green range, of about 61. Then it goes down here, moving along the X direction back to a green range, and then down to a low range that's close to 0 on this end. So you can get plots of along edges and along the selected nodes in the model. Um, let's see, other examples of what you can do with the results. Let me go ahead and specify a face instead of the edge. I can go to the integrate command. The default starts out with just doing the area side and then compute it. So this tells me what the area is of all of these selected faces. So this turns out to be 0.72 inch squared. I also have a lot of options here, some of which are not applicable because they relate to heat and thermal simulations. But I can go ahead and do the normal force and do compute. And this tells me that the normal force is almost, there's some mathematical approximations in here, but it's about minus 97, so it's close to the 100 pounds that I'm applying. I can also bring up my cutting plane, set it for the YZ direction. Here we go, YZ, and turn this on. Let's see, okay, here we go. I can move this around, and then for a section of the model, I can do the integrate command, and then there's a button up here that says use the cutting plane. So instead of using whatever I've selected, whatever faces have been selected, I can integrate on the cutting plane, and I can do the area, or I can go ahead and do the normal force, compute, and this tells me that right here the normal force is 99.78 for the integrated normal force. I can move this to a different part of the model and compute, and again the force is close to, computed over this whole surface, is close to 99.78. This is kind of what we'd expect. The stresses get larger because of the amount of material, but pretty much the total force that we're applying to this end gets applied all throughout the model. So that's an example of integrating quantities on the cutting plane. That's it for a quick introduction to results. Thank you very much.